Jacopo and my name is Aniket Daptari. We represent the Contrail product management team. And I have a couple colleagues from the rest of the BU in the audience. I have Vivek and Prasad from the engineering team. So what we are here to talk about is to give you a little bit of history and background as to how did things start off, and then what's the path forward, how we are kind of progressing along into our foray into other products that are built on that foundation. So as soon as the laptop cooperates. So you guys are probably familiar that Contrail was the product of an acquisition. Juniper acquired this startup called Contrail Systems back in late 2012, and it was one of a wave of acquisitions in the industry. And Juniper acquired this company because both the product and the people fit Juniper's DNA quite well. Now, we acquired the company late 2012. There's the slides. We acquired the company late 2012. The first generally available product offering out of that acquisition came September 2013. And since since the product was first generally available, it was completely, entirely put in the open source. And Randy has covered all aspects of the open source-ness of that offering. Now, this was a little unheard of in the networking industry, that we put our solution, our product, completely, entirely in the open source domain. The other thing that's a little different or a little unique about Contrail is that it's an entirely software offering. So now I have my slides on. The agenda is really simple. I'll give a little bit of a background, which is what I'm doing right now, and then just go on. So I'm going to focus on Contrail security. And so I'll cover the why, what, and how of Contrail security. What's the problem statement we are trying to solve, what the product actually is, and how it actually solves it. Right? So I'll keep it real simple, and then I'll hand it off to Jacopo, who will cover Contrail's multi-cloud and fabric feature sets. So what happened with Contrail was that it was trying to fundamentally solve these set of problems. So what we observed in any customer environment was infrastructure was A, heterogeneous, and B, distributed. And what customers wanted was first to be able to connect all this heterogeneous distributed infrastructure together, and then on top of that connectivity foundation, be able to secure and then manage and operate all that heterogeneous distributed infrastructure. And this is the vision, the goal that we operate off of. I don't want to spend too much time on this slide, but just at a very, very high level, that's kind of what we are working off of. Now, what we envision an operator workflow being when they're setting out to build clouds, and again, I don't want to spend too much time on this slide, but just going from 10,000 to about 7.5 or 5,000 feet, what is the vision that we kind of are working off of? The vision is operators log on to some kind of a portal, and then they're provided with a different number of options to select from. So the first thing they want to do is potentially build a fabric. So what it means to build a fabric, so they'll be prompted to provide a bunch of different options, different configuration parameters, and as a result of that, what's going to happen is the fabric is going to be provisioned. Now, what it means to build a fabric, which is going to be covered in extensive detail in Jacopo's portion. So what it means to build a fabric is to first interconnect all the network devices, then bring up the servers, the operating systems on the servers, make sure the networking is all configured correctly. So you're building that network fabric. And then the next thing you want to do is to enable hybrid connectivity, which means to extend this on-premise deployment with a public cloud. So everything that entails that hybrid connectivity would be taken care of. The next thing you want to do is now instantiate pods of potentially OpenStack or OpenShift, and then also provide overlay networking on top of this fabric that we've built. So that's the next step that's going to happen. And then once those pods are instantiated, you want to secure those, and you want to have consistent same set of security across all your environments. So that's the next step that's going to happen. And then you want to manage the user connections, and then you also want to monitor and have analytics across all your different environments. So that's kind of the operator workflow vision that we are operating off of. And so these are the services that we offer, and those are reflected in the product offerings that we have. So these are the product offerings. Traditionally, we've had Contrail networking. And then last quarter of 2017, we had 2 new product offerings built on top of the foundation of Contrail networking. It leverages the components that Contrail networking was built on top of, the architecture that Contrail networking was built on top of. And we have a standalone dedicated product offering for Contrail security. We have a converged integrated stack of software for deploying clouds, targeted mostly for the telco service providers kind of customers. And then what's coming this year is the Contrail networking with dedicated features for multi-cloud and the fabric use cases. So this is how the product line is evolving from the fundamental Contrail networking offering. Now, you guys are very familiar with this architecture. Again, the goal is not to spend a lot of time, but I just want to remind you all that this is the basic architecture of Contrail networking. There are 2, so let me remind you that it's all software. It has primarily 2 components, like any network offering. It has a logically centralized, but potentially physically distributed controller. And then on every server, on every server where you have application or tenant workloads, you have this entity called vRouter, which we also call as FER node, Forwarding, Enforcement, and Reporting node. Now, I like to provide an analogy that this actually this model, this architecture is very akin to a classical networking chassis-based router. Think of the controller as the route engine. The route engine, typically, you have an active and a backup. In the case of the controller, it's all software, so you can have more than just 2 copies. You can have n copies, depending on the degree of fault tolerance you want to build into your architecture. So you can have n copies all serving as active. And think of the server as a line card. Now, on a line card, you have data ports, and on the data ports, you have sources of traffic. So think of these VMs and containers that run on the servers as those sources of traffic sitting on data ports. And then think of the vRouter, or the FER node, as we like to call it, as the packet forwarding engine. Now, you run a bunch of control plane protocols on the controller. And a result of those control plane protocols translates to a bunch of routes and policies or firewalls. Those get programmed into the packet forwarding engine so that the packet forwarding engine can do fully distributed forwarding, fully distributed firewalling, and a bunch of other networking services. So that's exactly the model, the result of the control plane protocols that run in the controller. You program the vRouter, and then the vRouter is able to provide fully distributed forwarding and fully distributed firewalling and a whole bunch of other networking services. So that's exactly the model here. Now, I'm sure you guys are familiar, but I'll just remind you that it's BGP control plane. And in order to implement the overlay, we construct overlay tunnels. To construct those overlay tunnels, the technologies we employ are MPLS over GRE, MPLS over UDP, or VXLAN. We are agnostic to the tunneling encapsulation, but we support multiple different tunneling encapsulations. Now, this is all classic Contrail networking. So the focus of the presentation is not on this. It's on Contrail security. So let me quickly get to that. This is all the foundation. So the question is, why Contrail security? Now, we saw that customers have heterogeneous and distributed infrastructure. And what we observed our customers facing was an explosion in the number of policy rules they were having to write to adequately secure their environment. And fundamentally, that stemmed from from adopting or embracing the traditional model or traditional security paradigm. Now, what were the challenges of the traditional security paradigm? The first challenge was that customers relied on securing the perimeter. They thought that the bad entities resided outside the perimeter, and they thought that securing the perimeter was sufficient. And our hypothesis, our proposition is that securing the perimeter is necessary, but definitely not sufficient, simply because modern applications are more and more distributed. They are distributed across multiple data centers, across multiple clouds, private and public. And so as applications are distributed, the perimeter itself is distributed. Now, consumption of infrastructure, whether you talk about compute, storage, or networking, is increasingly software defined. What that means is the consumers of infrastructure consume those infrastructure, compute, storage, and networking programmatically by invoking APIs. And so the administrators are not in the way of consumption of infrastructure. What about security? Do central security administration teams still need to provision all these security policies? Yes, they do. And therefore, a decentralization of the definition of the security posture needed to happen. The third thing was in cloud environments, workloads are very dynamic and constantly mobile. So if you write security policies that leverage network coordinates to identify the endpoints that need to be protected, then as a consequence of workload mobility, we have to constantly update the network coordinates. So when a workload moves from one compute to the other, or from one data center to the other, or from one cloud to the other, its network coordinates have obviously changed. And therefore, the security policy that leverages the network coordinates to define what needs to be secured, that needs to be updated to reflect the new network coordinates. That obviously doesn't scale really, really well. So those are some of the reasons. Those are some of the challenges associated with the traditional.
So I think it's important to expand on something that you said earlier, where the security is perimeter-based, but perimeter is everywhere. What that means is that the typical enterprise model of here is the internet, and out here be dragons, and I'm going to put this magic box in the middle, and the magic box is going to make all the dragons go away.
Right.
That is no longer a valid architecture.
Absolutely.
And addressing that, as you have very well stated, is difficult to deal with. Not just because that's not the way it's typically done in enterprise, but it's just hard to do no matter what.
Absolutely, spot on.
And
the other thing is you're not going to be all in.
Right.
You're not going to be all in with AWS.
Right.
You're not going to be all in with Azure. You're not going to be able to say, I'm just going to use Azure features for this.
Yes.
Because the reality is you're going to have a branch which is using Office 365 for mail, Salesforce and Salesforce SaaS apps over there, and you're going to be at some other service, and you're going to have something in Google Compute, and you're going to have to build a security platform across all of those.
Right, because your data exists inside those as well.
And that's why you can't look at a startup architecture and say, oh, look at them, they're in AWS and using AWS to be secure.
Yep.
But the point is that you're not just in AWS.
Right.
You're all over the place. It's actually, this is what I say about networking gets more complicated, not less.
It's more fractured.
Yes.
Yeah, and your security is maybe like an onion with many layers, and you have to provision all of these layers,
Yes.
when your applications are moving or something is going on.
So with Contrail networking, what we were able to do is to have consistent and seamless same set of network primitives across all these different environments. Like he was alluding to, you're not all in AWS, right? So across all your environments, you want consistent networking. We got that with Contrail networking. That's the goal with Contrail security. You have consistent and same set of network security primitives now. The other point I quickly want to add is when the perimeter is breached, I want to make sure that the attack doesn't kind of spread. So I want to limit the spread, lateral spread of bad things, attacks, malware, etc. So that's the other thing we want to cover with Contrail security as a goal.
And can I ask, so you have Workday up on the slide, and you mentioned Salesforce before, where that's not something that you have any kind of equipment or anything actually running in their environment. How are you kind of applying the Contrail security to something where it's just a kind of a data living in someone else's system?
So exactly. So right now, we are securing applications that run and reside either in owned data centers, private clouds, or in public clouds. But something like Salesforce that runs that's a software as a service kind of an application that runs in Salesforce's premises or clouds, we don't secure that. But we can secure the place where the traffic destined to Salesforce originates from.
Okay.
So that is what we can secure.
So as close as you can, monitor that to and fro. Okay.
Yes.
But even with public cloud, can you talk a little bit more about the integrations with AWS, with Azure, with Google, because they're all very different.
Yeah.
There's,
think
their own monolith from each to the other.
So there's some element of that covered in the multi-cloud portion.
Okay.
But very quickly, I'll just say this. So ultimately, whether it's, regardless of which public cloud it is, ultimately what you're renting from the public cloud is some compute. And within that compute, you're running an operating system. Now, our software relies on running that the vRouter component for fully distributed enforcement of security policies as well as fully distributed forwarding. So as long as we can run that vRouter component within that public cloud instance, we are good. You have the exact same consistent networking and security. Now, there may be cases where customers are averse to running that vRouter software within your, let's say, an EC2 instance. If that's the case, then what we also are working on is to use the APIs provided by the public cloud provider. And what you do on-prem, we'll find the equivalent in the public cloud and use the public cloud provider's APIs to get the equivalent security in the public.
It's basically the concept of networking as a service, not confined in a single cloud domain, which might be the private cloud data center or the public cloud with a full stack of SDN control and enforcement points. But extending networking as a service across the boundaries of multiple clouds so that you can effectively detect and enforce policies across workloads which may be sitting across heterogeneous environments. So that's the part we're going to cover later in the second half.
And you guys are going to cover based on intent for the different. So I don't have to care.
Yes.
I need to make this API call.
Exactly.
Yes.
Thing and all that. It's
Absolutely.
all intent-based. Okay.
So Contrail has been about the abstraction, and abstraction translates to express intent and then do what it takes. Okay. So we also call our controller as a compiler. It compiles intent, the abstract expression of intent, into whatever lower level constructs it means to achieve that forwarding, firewalling, secure multi-tenancy, even doing service chaining. All of those are the lower level constructs that are interpreted, that are inferred from abstract expression of intent. So that theme continues. So to substantiate the problem statement a little further, how does the symptom of policy explosion actually manifest? Now, if you look at applications, a lot of customers are building applications, and typically as applications are built, they start in the dev environment, and then they progress or graduate into a staging and then into a production environment. Now, this is what's happening here. Regardless of the environment the application is in, the application itself remains the same, its tiers, its components remain the same, and therefore its security requirements remain the same. But notice what we end up doing. We instantiate the policy per environment the application is deployed in. And this is just one symptom or one cause that contributes to the explosion of the number of policies. So ideally what we want is, regardless of the environment the applications are deployed in, if we can have one instance of the policy that's more fungible and that applies to the application regardless of the environment it's deployed in, that's what we desire. And if we are able to accomplish that, notice that there's an obvious savings in the number of policy rules, and therefore that can alleviate the problem of policy explosion. I'll take this example a little further. So obviously, if we are able to accomplish that, we get reduced complexity, we can manage it better, and things scale much better. I'll take the same problem a little bit further, because the problem is exacerbated when there's a group within the organization that says, hey, the app component, I'm going to deploy it in the public cloud. Or the web component, I'm going to start deploying in the public cloud or start building it in the public cloud. So somebody takes the application to the public cloud. Another group comes along and says, I'm going to start containerizing this portion, or I'm going to start take a stab at containerizing it, and I think Kubernetes is the right orchestrator. Another group says, yes, but Mesos is a better orchestrator. The ops guys say, hey, when it comes to deploying this application in production, nothing beats bare metal servers. So I'm going to deploy this application on bare metal servers. So now what you see is not only are there different environments that the application is deployed in, but there are also different form factors of the same application. And so this leads to worsening, exacerbating of that policy explosion phenomenon. And therefore, to contain the policy explosion phenomenon, what we want to be able to do is to define, review, and approve the policy once, and then be able to use that policy everywhere. Now,
I'll wait. Go ahead.
OK.
I'll wait.
Now, while that is happening, what we also want to do is to decentralize the expression of security intent and let application developers who are building applications, they understand their application, right? So let them, as they are building their application, express the intent, the abstracted security intent as they are building the application, and let us translate those, like let Contrail translate those into what effective security policies that translates to. Now, but while we do that, decentralize the expression of the security posture, we want to make sure that the central security administration teams, they still retain the authority, they still retain the oversight, and for reasons of compliance or for other reasons, when they need to enforce policies that apply org-wide, that should always also be possible. Decentralization is a goal, but there should always be the possibility that there are org-wide policies that the central security administration teams want to enforce, and that should always be possible.